been awesome. What an amazing venue, amazing lineup of speakers. And they asked me to come along and close out today. I said, what do you want me to talk about? And they went, just come along and do something interesting. And I like it when people give me that brief, because it means I get to talk about stuff that I like, but hopefully there's going to be some stuff in here, which is stuff that you like as well. So the title of my talk today is From ACK to ZOI, the story of software in 3-letter acronyms. And I was talking to someone at one of the sponsor booths, and they went, but none of those things are acronyms. You need to change the title of the talk. So this is the short version of the talk. This is A to Z, the SOS and TLAs. My name is Dylan Beattie. I do fun things with computers and code and music and video and comedy, and then I travel around the world and I tell stories about what I did, and apparently it's working because they keep inviting me back. I started my own company in January 2020 to do, can we kill the monitors while I'm talking, please? Completely dead, thank you. Yeah, started my own company January 2020 to do lots of international traveling. That's the dumbest idea anyone ever had. I'm an MVP, I run the London.NET user group, and I once invented a programming language in a bar as a joke, where all of your programs are heavy metal songs that you can compile. And the whole point of that is that it is a programming language called Rockstar, and it's very easy to learn, so anyone can become a Rockstar developer. And since I did that, people on LinkedIn have stopped advertising for Rockstar programmers because they just get a bunch of guys going, look, Black Sabbath lyrics, look what I made. So yeah, that's me. And like I said, we are here at Azure Lowlands, and we are going to take a tour through the history of software and technology through the medium of 3-letter acronyms. Well, not entirely, because there are acronyms, and there are initialisms, and there are abbreviations. And if you're being technically correct, they are different. DLL is an initialism, because we don't say DLL, we say DLL. FTP is an initialism, because we don't say FTP, and we don't say Ibm, we say IBM. These are initialisms. Acronyms are things you pronounce as a word. COM is an acronym. Clicky. Laser is an acronym. It stands for something. NASA is an acronym. These are things we pronounce as words. And then there's the funny little bit over in the middle here, which is the things we're not sure about. Anyone here say SQL? Because some of you will say SQL, and some of you say SQL. And I did once meet a guy who called it squirrel, but we don't talk about that. And like some people say FAQ, some people say FAQ. So these ones, we are not sure. And the first thing that we're going to meet, actually it's not an initialism or an acronym, it's an abbreviation. A is for ACK. ACK is short for acknowledgement. And before you start talking to somebody, whether you are a presenter talking to an audience or you're a client talking to a server, the first thing you want to do is kind of ping them and go, hey, you ready? Are you listening? Is it time to have this conversation? And this is known as the three-way handshake. It is how the internet works. When your client connects to a web server, the first thing it does is send a packet going, hey, Sin, can we synchronize, please? And the server says, yes, we can synchronize. Please acknowledge that we are going to synchronize. And you get a reply back saying, ACK, I acknowledge that. Now, the astonishing thing, TCP/IP, is it is a reliable protocol. TCP/IP is the sturdy Volvo of computer networking, which is amazing, because TCP runs on top of a transport layer called IP, the internet protocol, which looks like this. IP does not guarantee anything. TCP says if I send you 2,000 packets, you will get all 2,000 packets in exactly the right order, one after another. IP says, I put it on the internet and I don't know where it went after that. And the whole way that TCP works is every one of those IP packets has a synchronization number and an acknowledgement. Hey, here's packet number 1. Did you get it? Here's packet number 2. Did you get it? Here's packet number 8. Did you get it? Here's 7. Here's 10. Here's 5. And the network stack on the other end puts all those things back together as it goes along. And this is how we get reliable networking over an unreliable transport layer. Now, this stuff dates back to the 1980s. TCP/IP, actually 1977. Is when TCP/IP was first put together. It was ratified in this thing from 1982, and it was January 1st, 1983. It was called Flag Day. That was the day that the whole internet switched over to running TCP/IP, and it's still in use today. IPv4 and all these technologies, we're still using them, all of us, all day, every day. Now, that was just one of a whole raft of technologies from the early 1980s which had a profound impact on the future of computing and technology. Let's meet a couple more of them. Now, around the 1980s, some of you may remember a thing, the BBC Micro. This was a big deal in the UK, and it was influential because of the number of British developers who wrote games and software on this thing. Now, this was created and sold by the BBC, the British Broadcasting Corporation, but it was manufactured by a company called Acorn. And Acorn would go on to create the first reduced instruction set computer, the Acorn RISC machine. Now, if any of you remember a thing called the Archimedes was an Acorn RISC machine, and it was kind of successful, and it was so successful they changed the name of the company to ARM Holdings. Today, ARM Holdings is worth $3 billion. They make the CPUs that is in probably every smartphone in this room. They license their chip manufacturer designs to companies all over the world. They don't make anything. All they do is design processors. But from a recent press release they put out, ARM technology is in 190 billion devices and 95% of today's smartphones, which is a pretty good track record for a company that started out making the BBC Micro so they could put it in schools and teach kids how to do programming. And of course, the BBC has been influential in other ways. Any Python developers in? Python is named after Monty Python, BBC television show. IBM, Deep Thought, the supercomputer that beat Garry Kasparov at chess, named after The Hitchhiker's Guide to the Galaxy, which started as a BBC radio program. And Tomorrow's World and Doctor Who and the BBC has just been hugely influential in all kinds of ways, in inspiring generations of nerds to go and do interesting things with electricity. Now, while this is going on in the UK and in Europe, over the other side in the United States, IBM are getting a little bit worried. Now, IBM is an initialism, International Business Machines, and IBM's been around a long time. Like, they started out in the 1920s. This is from a YouTube video that you can find. In 1934, IBM made this. This is a mechanical cheese cutter where you adjust the dial for how expensive the cheese is, and then you cut the slice of cheese you want, and it tells you how much it costs. This was an international business machine in the days before microprocessors and technology. And, by the 1950s, IBM's building business automation systems. By the 1970s, they are building the mainframes that are going to dominate business computing. But by 1980, IBM are thinking, we got a problem here. There's people selling computers for a few $100s that will actually fit in your house, let alone needing an entire room to put them in. And they realized the only way IBM's going to remain competitive is to get a product into the home computer market, and so they launched this, the Ibm Pc, built out of off-the-shelf components, which was not how IBM did things, and easy to clone. You could go into a store and buy all the same parts that IBM were buying. You needed to invent your own BIOS, so people came up with ways of reverse engineering that. And they needed an operating system, and their shortlist came down to two contenders. C is for CP/M, and D is for DOS. Now, there's a lovely story that Microsoft went to see Gary Kildall, the head of digital research, who wrote CP/M, and said, we want to buy your operating system for our computer. But he was out that day because it was a nice day, so he'd gone flying in his plane. Apparently not true. He was just busy with something else. But IBM eventually they did a deal with Microsoft. They licensed MS-DOS, and that became the de facto operating system for the PC. But what Microsoft had realized is that the PC didn't matter because anyone could build one of those. What mattered was the operating system behind it. And so they kept the right to sell DOS to people who weren't buying IBM. Now, I started my sort of serious computing career on DOS. I had an IBM PC, or an IBM clone, IBM-compatible PC, that came with MS-DOS 4 on it, on some handwritten disks. And I don't think that Bill Gates and Microsoft ever got any money from that copy of MS-DOS. I'm just kind of speculating here. Because within my lifetime, the issue of software and copyright has become a really big deal. It used to be that you would go to a computer meet. This is back in the 1960s. There was no point selling software because every computer was unique. So if you gave someone else a program, they couldn't just run it on their computer. They'd take it back to their lab or back to their company, and they'd have to figure out how to adapt the code, how to import the routines. And hobby groups would get together, and it wasn't until the boom of home computers, where suddenly you had 100 people whose computer was the same, that there was any reason to swap software. Open source was the model we started with. Yeah, here's my code. You can't run it, so it's not worth anything. You are welcome to look at it. Now this is a photograph of the paper tape that had Altair BASIC on it from 1975. The Altair was an 8-bit home computer. You had to bolt it together and solder it together yourself. But one of the reasons it was popular is you didn't have to program it in machine code or assembler. You could run BASIC on it. And so people would take these tapes along to computer meetups, and they would give them out and swap them with their friends. And the people who created Altair BASIC, they were not terribly keen on this state of affairs. This was a letter to hobbyists written by some guy called Bill something, who was a general partner at Micro-Soft back before they lost the hyphen, where he's basically saying to all these people, look, we wrote BASIC. We paid people to write BASIC. These are our programmers. They have a job. Every time you go out and give out copies of that, you're basically stealing from us. And this started this whole dialogue about commercial versus open source, intellectual property, piracy. And, recently it's not just code that we're concerned about, it's data. Never mind who owns the programs, who owns the information. If I book an airline ticket and I put in my name, my passport number, where I'm going, am I vegetarian, somebody can sell that data. Do I own it? Does the airline own it? Can the airline sell it? What if they take my name off and they're just like, we want to know the age, gender, and whether people are vegetarian and which cities are they going to? Is that data I have any right to refuse them? Now, the next section of Alphabet is the people who are helping us figure this stuff out. E is for the Electronic Frontier Foundation. Now, this is a group of activists, legal advisors, and technologists who are watching what is happening with data and ownership in the world around us and what happens with it. Let's imagine, for example, that I somehow get a copy of the source code to Candy Crush Christmas, and I have that on my desktop. It's not mine. I've not paid for it. I have no license to it. But I right-click, send to mail recipient, and I send it to you. You now have stolen property in your inbox. That makes you an accessory. You're a criminal. Should you go to jail for having that? Is it any defense to turn around and say, well, I didn't know I had it? This is exactly what the Electronic Frontier Foundation is trying to do, to work with organizations and governments around the world to help them get this stuff right before it ends up in a court case that could set a horrific precedent. Now, F is one extreme of this. F is our friends at the FBI. And all I'm going to say about the FBI is if you've ever had a website where you would go to download things and then you turn up one day and it's got this on it, you get a little bit frightened just for a second. You're like, was I on a VPN? Was this a good idea for me? And at the other extreme is G, which stands for GNU, which is our first recursive acronym. Because the G in GNU stands for GNU, because GNU's not Unix. And if you say, well, what's the GNU for? Well, GNU's not Unix. Well, what's the GNU for? Which is incredibly funny if you're Richard Stallman. And GNU was a project established in 1983, again, same year, to build a completely free, open, unrestricted copy of the Unix operating system. And they almost got there. They had a compiler, they had editors, they had linkers, they had assembler tools, they had all kinds of things. What they didn't have was an operating system kernel until a Finnish guy called Linus Torvalds, who needs no introduction, pops up in the early 90s and says, hey, I made a clone of Unix for my IBM 386 PC, and it's here and it's free, and it's just a hobby project. It'll never be anything big. It'll only support ATA hard drives because that's all I can afford. And that was the missing piece of the puzzle. GNU Linux went on to become the dominant server operating system, and if any of you in here is running an Android phone in your pocket, that is a direct descendant of the GNU Linux operating system. Now, we talked a little bit about the BBC Micro, and my enduring memory of the BBC was this: Elite. This was an astonishing engineering achievement. It was a game, 8 galaxies with 8,000 procedurally generated star systems in each of them, 20 or 30 different ships you could fly around in, trading, combat, pirates, hyperspace. It was brilliant. And when you loaded Elite on your BBC Micro, it would play this funny little rendition of the Blue Danube Waltz. And the reason it did that is because it was inspired by a scene from this, Stanley Kubrick's 2001: A Space Odyssey. Now, this was and is a very divisive movie. It came out in 1968. Some people say it is the best film of all time. Some people say it is long, pedestrian, dull, and monumentally unimaginative, is a direct quote from something. But when this film was first released, it was praised for its scientific accuracy. It was a science fiction movie developed as a collaboration between Kubrick and a British science fiction writer, Arthur C. Clarke. And it has no lightsabers. It has no time travel, no flux capacitors, no magic. It was a serious attempt to try and make a film about what it might look like if human beings actually had a colony on the moon. And one of the most iconic creations in that movie is the H in our tour of the alphabet, HAL 9000. Now, spoiler alert, the film has only been out for 55 years, but in case you haven't seen it, put your fingers in your ears. There is a scene in that movie where the computer kills one of the crew. HAL is the onboard computer, heuristic algorithmic logic. And one of the crew has gone outside to investigate something and is trying to get back into the spacecraft. And there's that chilling scene where he's opened the pod bay doors, HAL, and this computer voice comes back, "I'm sorry, Dave. I'm afraid I can't do that." And people have debated for decades, was HAL malfunctioning, or was HAL actually programmed to kill the astronauts for the success of the mission? Now, you know, haha, lol, science fiction, imagine a computer being programmed to kill human beings. That's not science fiction anymore. We have autonomous vehicles, we have self-driving cars, we have smart navigation aids. We have so many ways now where the idea of should a computer be programmed to kill a person, and if so, which person, and how does it choose? These things are not hypothetical anymore. They are real things that we need to start thinking about. Now, there is a wonderful anecdote about 2001: A Space Odyssey, that the computer was called HAL, because you know when you go to school, if you get an A on the paper, A is better than B, and a B is better than a C. And the joke was that HAL was one better than IBM. And it's not true at all. It was a total coincidence, and it was an embarrassing coincidence because IBM actually contributed loads of hardware and technical support and advice to the people who made the movie. If you watch that film closely, all the spacecraft have IBM control systems, because if you wanted to sell realistic spaceflight to cinema audiences in 1968, a year before human beings actually walked on the moon, you did it by making it look like they had gone to IBM. Now, IBM is a huge and hugely influential company. When I was putting details for this talk together, IBM has averaged over 4 patents a day for more than 100 years. The Nobel Prize has been won by an IBM employee 5 times. Or 5 different employees, it wasn't the same person. But IBM kind of has this reputation. Like, who thinks IBM is cool? Like, they're important, and they do big consultancy, and they've got their own cloud that you can use if you don't want to use AWS. But IBM have never been perceived as cool, certainly not within my career. They're always, people in suits who sell big companies and big computers and mainframes and all this kind of stuff. And it kind of comes down to, for a lot of us, technology is not just about a job. It's not something we do. It becomes tied up with our identity. Who are we? Are we the suits? This, by the way, is literally from an IBM brochure about IBM fashion and style from the 1980s. Or are we the hackers with the weird hair and the piercings and, the leather jackets and all that kind of stuff? And this comes up in all kinds of ways throughout computing science. Choice of laptops, Mac or PC, programming languages, platforms, where you deploy your software. And there's an interesting example of it from around about 20 years ago when everyone in suits was getting very excited about web services with SOAP and Disco and the WSDL, web service description language, and the future definitely belonged to XML because, as you can see, XML is awesome, apparently that's false. Now, this was a nice idea, but XML kind of sucked. Like, I've worked with lots of XML, and I don't enjoy it. It feels like pretending to wear a suit for a living in a weird way I can't really explain. And then this guy comes along. This is Douglas Crockford. If you've ever seen that famous picture of JavaScript, the Complete Guide, which is a book like this, and JavaScript, the Good Parts, which is a book like this, he wrote the good parts. And he was the first person who went, hang on, if we take JavaScript code and we take out all the functions and the methods, we are left with JavaScript object notation, which was going to be called the JavaScript markup language, JSML, until someone said that's not a markup language, and he's like, all right, JSON or JSON or JSON or however you want to pronounce it. And JSON became the de facto language of people doing stuff on the web who don't work for IBM. Like you want to do big enterprise integration with banks, you're still going to have to do XML and sign it. But a lot of us were like, nah, this is cool, look at it. It's like a database that you can run, it's got stuff in it. Now, the first time I saw JSON, I thought it was brilliant. And I still do. I think it's a really, really clever, elegant format. But the thing that made JSON remarkable is that if you'd said at the time, we need a serialization format that web browsers can interpret natively, that would have been like a 5-year coordinated engineering project across half a dozen different companies. But by going, well, hang on, JavaScript already has an eval operator. If we just use this, then the code turns into data without us having to add anything to the browser. That, I think, is a brilliant example of taking something that already existed and repurposing it to solve the kind of problems we were dealing with. Now, on the subject of repurposing things that already exist, we're going to talk about scientific units now, because we're going to talk about K. Because we know about K, right? I mean, these days we tend to talk about megs or gigs, but back in the day, 32K was not very much, and 64K was quite impressive, and 128K, well, now you're talking about the spectrum, and you're really getting somewhere with it. And, K is 1 kilobyte. Or is it? Because scientists, serious people are like, well, obviously it's 1,000 bytes, 10 to the 3, because if you have 8 fingers and 2 thumbs, 10 is a nice round number. But digital computers are like, I don't have fingers or thumbs. I got registers, and they can be on or off. For me, 2 is a nice round number. So for computers, K became a kilobyte, 1,024. Now, this didn't matter for a long time. Nobody really cared until hard drives got big. Because if you take a 250 gig hard drive, and you say, well, 1 kilobyte is 1,000 bytes, so clearly 1 gigabyte is that many, which means 1 terabyte is that many. Click. I've got the short-range Bluetooth here. I'm going to stand like this. Actually, let me move that so that the antenna's kind of sticking up there. This is 25 years since 50 years since the BBC Micro, and we still haven't got this stuff right. So there we go. But then if you say a kilobyte is 1,024, that means a gig is this much, which means 250 gigs is this much. So the difference between those, that's over 16 gigs. However you measure it, metric gigs or computery gigs. And so hard drive manufacturers are like, oh, well, if we use that one, then we only need to put this many bits on the disk, and we can sell it as a 250 gig hard drive. And so a solution was proposed by the International Electrotechnical Commission, who said, we've got a good idea, boys. What about a new set of units? Kilo always refers to 1,000, and if you need to refer to a binary kilobyte, that's a kibibyte. Has anyone here ever said the word kibibyte out loud? Like, ever? Yeah? Or a mebibyte? Or a gibibyte? Now, these things kind of look fine when they're written down, and when you say them out loud, you're like, gibibyte. Like, no, I don't want gibibyte hard drives. That just sounds silly. But that's the solution that they came up with. The official solution here is that a kilobyte and a megabyte and a gigabyte are powers of 10, and if powers of 2, kibibytes, mebibytes, and gibibytes. Now, measuring hard drive space, yeah, no big deal. We kind of figured that out. But the other big sort of revolution that's happened recently when it comes to measuring megs and gigs and stuff is networking. And L is for LAN, local area networks. And by extension, we have storage area networks, which is the network that only talks to other hard drives. And personal area networks, which is the little cloud of devices floating around in your luggage that are all chattering away to one another. Now, does anyone recognize this? This is a coaxial network terminator. And my first proper job was doing help desk at a company whose office used coaxial networking. Now, coaxial networking looks like this. You have a wire coming out of the server rack, and it runs all the way through the office, and every time you need to add a computer, you just split the cable and you put in a T-piece. And if anything goes wrong anywhere on this wire, any of those connectors gets knocked, loose, disconnected, all of the computers lose the network connection. And this is in the days when if you unplugged Microsoft Word from the network, it would lose all your work and then crash and die. So people got quite upset. Now, you could run 185 meters of cable on one of these cable runs. So my first networking job, about once a week, week there would be a problem, and I would be crawling on my hands and knees, underneath desks and around the back bookshelves, trying to find the place where this thing, and just going through and literally connecting every single one of these up. Now, we have advanced a great deal. Networking technology has got a significantly better and more reliable. The invention of RJ45 connectors, where you have one wire for each computer, that was a big deal. And then we invented wireless, which is an even better big deal. And if you've ever wondered why hard drives are measured in gigabits or whatever, gigabytes, but networking is measured in megabits and gigabits, the main reason for that is that when we put data on a disk, we kind of know how many of those bits we're going to be able to use. Because we know we need a header, and then we know that we can store bits, byte, 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 byte. With networking, we don't actually know. We know how many bits we can get, but we don't know how many of them are going to make it through in one piece because of this whole TCP acknowledgement and synchronization thing. And so on a network, every byte has a header and then a footer, and a header and a footer, and a header and a footer. And so the network industry are like, we're not actually going to tell you, because if we tell you 50 megabyte internet, and you can't download a 50 megabyte file in a second, you're going to get upset, you're going to complain. So we're going to call it megabits because we know that you don't know what those are, and that's just how it works now. So when you get your 50 megabit or your 100 megabit broadband, it's megabits, not megabytes. And that's a big deal because we like downloading stuff. And today you can download just about anything. We just had 2 years of doing live-streamed conferences where we're sending each other high-definition video all around the planet in real time. But for developers of a certain age like myself, our love affair with downloading goes to M, which is a meta abbreviation, because MP3 is short for MPEG Layer 3, and MPEG is short for the Motion Picture Experts Group. And I was there when the MP3 revolution happened, and it happened because of a convergence of 3 pieces of technology that all landed in the right place at the right time. The first one was the Pentium 75 processor. Now, the one before this, that was the Pentium 60. The Pentium 60 was not fast enough to decode MP3 in real time, which meant you couldn't listen to them. You could decompress them into WAV files, and then you could play the WAV files, but you could not click an MP3 and actually play it. The Pentium 75 was fast enough to do that. Second, Winamp. It really whips the llama's ass, right? I still use Winamp. I use Winamp for running live streams and stuff because it is a fantastically reliable piece of software, and it looked cool. Like, it does not look like Microsoft Office 95. It's like black and green and shiny. And the third thing was that almost every computer sold in the 90s had a CD-ROM drive, which meant you could borrow a CD, stick it in, rip it, there you go, there are your MP3s. All you need now is a way of sharing them with all your friends, and boom, Napster was born. And you're like, here is my entire music library, share it with every single person on the planet for no readily apparent reason. And yeah, I still got some stuff on Napster that I've never managed to find anywhere else. Like, I got that folder of rare MP3s and bootlegs and all this kind of stuff. And of course, this precipitated another complicated round of shenanigans about intellectual property and piracy and theft. And you wouldn't download a car, and it's like, if I could get it from Napster, I would. Like, who are you trying to convince here? And this gets us into something interesting that has happened very recently. Because it's been said that there is a pendulum in society that sort of swings from liberal to conservative and back again. And 25 years ago, if you were cool and you were doing edgy things on the internet, the idea of owning bits was absolutely abhorrent. Information wants to be free. Share all the things, put it out there, down with the man, nobody gets any money out of this. But within the last year or so, there's a very weird trend emerged, which is all to do with something called fungibility. Now then, how much is this worth? It's worth $1. It's a US $1 bill. It is guaranteed by the Federal Reserve Bank of the United States of America to be worth $1. But it's also worth $5,000 because this is a ladder bill. It has a sequential serial number. There are roughly 8,000 of these in circulation, and they are collector's items. If you can find a US dollar bill with a serial number that goes 1, 2, 3, 4, 5, 6, 7, 8, these go for round about $5,000 on the collector's market. So in one sense, this is fungible. It's a dollar that's good for any other dollar. You can swap it for, 10 of these, that equals a $10 bill. You can use it to buy stuff. When you go to the bank and you give them $1 and then you next day and they don't give you your dollar back. But if you gave them this dollar And you went back the next day, and they're like, that's not my dollar. I want my dollar. It had a special number on it. Because this is non-fungible. This has value in and of itself. Now, if you go on any stock photography library and you look for Bitcoin, you'll find pictures like this one. Like there it is, one shiny gold Bitcoin. This is not a real thing. These do not exist. Digital currency has never had a serial number. It is a store of value. Crypto, Ethereum, Bitcoin, all these kinds of things, it's just like you got this many and I've got that many, and here is a digital signature saying that I gave you this many, and then we'll copy that onto all the computers that are subscribed, and basically that's the blockchain in a nutshell, until someone went, well, hang on, what if we could invent cryptocurrency that did have serial numbers? And so the non-fungible token was born, and I'm kind of hoping that now we can say born and then died horribly. But maybe it's a little bit early to call that one. I did see this on the internet this morning, which I just wanted to drop in because it made me laugh. You told us to buy Ethereum at 4,000, now it's 1,000. This is why we don't love you. Fix it now. You know, crypto has had a bit of a rocky run this year. And last year, there was this massive spike in these things, you know, Bored Ape Yacht Club pictures and NFTs being sold online for hundreds of thousands of dollars. But of course, the stupid thing is when you open OpenSea in your browser, which is the marketplace for these things, it creates perfect digital replicas of all the art on your screen just so you can see it. So you've already got the art. The only reason anyone pays for it is that they want to be able to say, no, I own it. And it's like, well, you don't own it. What you own is a record in a blockchain saying that there's a server over there with a URL that belongs to you. And if we shut down a server, hey, you just bought the Mona Lisa, and then we destroyed the painting, but you get to keep the receipt. But actually, you never had the Mona Lisa. All you did was you paid for the receipt, and then you hoped somebody else was going to come along later. Now, I remember tracking down rare albums on vinyl and trying to find songs that, you know, I'd heard on the radio once and no record store knew where they were. I know what non-fungible media is like. And I think it is amazing now that you can go on Spotify or YouTube and you can find this stuff. You can find out-of-print books and read them on your Kindle. You can find records where they only ever pressed 100 copies of the CD, but now the catalog's licensed to Spotify. We have eliminated digital scarcity. All this stuff is available. There is a separate question about who should get paid for it. But that whole idea of you can't have that because it is rare, and there's only one copy in the world and you don't have it, so you can't enjoy it. I think it is astonishing that we've moved beyond that. So I think it's so strange that people are trying to recreate that just so they can get off owning it and selling it and getting rich on that. Now, eliminating digital scarcity, yeah, brilliant. Movies, digital. Music, digital. Books, digital. Digital media is no good unless you have a machine that you can go and look at it on. And so from MP3 to NFT to one of the most interesting projects in the history of technology, this one. Anyone familiar with these? One laptop per child. This was a project from the early 2000s that was a brainchild of these two people, Nicholas Negroponte, who ran the Media Lab at MIT, and a guy called Sima Papert, who was a scientist, mathematician. I think he was from South Africa, actually, and he was one of the co-creators of the Logo programming language. And they had a vision of a laptop that cost $100, that had a hand crank so it didn't require mains electricity. It had 802.11b mesh networking. So if you didn't have an internet connection, you could piggyback on the one from the next house over and do that all the way through the village until someone at the other end has got a modem or a telephone line. This thing, that prototype vision for it, it had a hybrid display, which is amazing. Imagine you take a Kindle, right, and crack the back off so all you've got is the high-definition LCD, and then put that on top of your iPad. So you've got a color screen behind it, and you've got a high-definition black and white screen in front, because the black and white screen's readable in sunlight, and it doesn't use any power, except when you're turning pages. So this was an incredibly advanced, vision for a piece of technology. It ran a custom distribution of Red Hat Linux. It had a custom GUI on it called Sugar. And even the way they distributed this, they did a thing called give one, get one. If you wanted one of these, and we did because we're nerds with disposable income, you had to buy two. And you'd get one, and the other one would be donated to a project in the developing world to help, these kids become information literate. Now, This thing was hugely controversial almost as soon as it was announced. They couldn't hit the price point of $100. They ended up going more like $200. They couldn't get the crank charging mechanism to work. It just wasn't reliable enough. The mesh networking thing, that didn't really take off. A lot of people were like, why are we giving kids a computer that doesn't run Microsoft Windows? Because, you know, we're teaching them to use weird free Linux. That's not going to get anyone a job. And a lot of people are like, if you're spending $100 on a kid, really, they could use fresh water and healthcare a lot more than they need a laptop running Red Hat Linux, you know. The project wasn't a complete write-off. They aimed to ship 15 million of these things. They shipped 600,000, mostly to countries in Central America. And by this point, many of them actually ended up running Windows because Microsoft just went, yeah, have the licenses. Like, we'd rather have our name and our software on this thing. But the impact of this, the foundation that was set up for this, shut down in about 2014. But the impact is still being felt today. In 2007, Asus launched this thing. This was a $100 laptop, the Asus E701. It ran Linux, which scared the crap out of Microsoft, and is probably one of the drivers towards Windows now being available as a free download. And if any of you out there has worked with a Google Chromebook or any of the ultra-lightweight kind of notebooks, this is the thing that made the whole world go, hang on, a laptop doesn't need to cost $1,000. Like, we've got the technology now, we've got cheaper operating systems, we've got cheaper components. If performance is not a consideration, we can go an awful lot cheaper. So, LMNOP is for POP3. Q we're going to come back to, and POP3 and SMTP were both defined in something called an RFC, request for comments. This is how the internet gets written. If someone says, I got a good idea, I think this might be how we can make it work. They put that on the web, and other people come along and go, yeah, this would be interesting. I have an idea. Why don't we do this part? And they start implementing it, and eventually it just becomes part of the set of standards that governs the internet. And one of the most influential of these was this one, 1982, the Simple Mail Transfer Protocol. Now, before SMTP, if you wanted to send someone electronic mail, you needed to specify a route. We called this thing a bang path. And if I wanted you to send me email, it's like, well, wherever you are in the world, your network can probably find Google. So you need to send a message to Google and send Google to tell it to Fastmail and tell Fastmail to send it to Ursatile, and then Ursatile knows who Dylan is. That was how email got there. And often these servers would only exchange mail overnight, so it was quite common to send an email that would take a week, 7 or 8 days to get there, which is no good if you're in a cab on the way to the airport and you realize you forgot to buy a ticket because you're like, okay, we've emailed your ticket, so you're like, all right. I guess I live at the airport for a week now. SMTP came along and it went, you know what? No, we're not going to do that. Mailbox@host.com. It combined DNS and it gave us a unified addressing system that meant people anywhere in the world could email each other reliably. And this took about 10, 12 years to take off. But if you were good with computers at a certain point in history, you could get a lot of free food and free beer and snacks and things just by knowing what to do with this box. Because everyone was going, we need the internet at home. And they'd go out, they'd buy a computer, they'd buy a modem, they'd click this thing, and then they'd be like, what do I put in these boxes here? And you'd be like, yeah, got any beers? I know what goes in those boxes. Now, you know, this was pretty revolutionary. Email, SMTP, you showed people the World Wide Web for the first time, it blew their mind. And, you know, this was and is phenomenal. But recently, the last couple of years, then remember October last year, Facebook went down? And Facebook took Instagram and WhatsApp down with it because someone accidentally locked Facebook out of all their own networks. So they couldn't get in remote because there's no network. They couldn't even, the people who drove to the data centers to actually go in and physically reboot things, they couldn't get in because the locks on the doors were using the same authentication on the same network that they had just disconnected. They ended up having to physically break doors down and stuff to get back in and get back online. Now, yeah, Facebook, WhatsApp, Instagram, there's a lot of people who are like, I didn't even notice, but there's a lot of people who are like, that's it. That is their only experience of the internet. Those things go down, and they're like, the internet has stopped working, and that's bad. Because the internet was designed to survive a nuclear war, and then Mark Zuckerberg managed to accomplish what, 30 years of nuclear standoffs didn't, and render the internet unusable for an awful lot of people. And as we increasingly stop using open protocols, we don't do email, we do WhatsApp. Well, great, until WhatsApp goes down. We don't have websites, we have Medium, and we have Tumblr, and we have Instagram. I know so many bars and restaurants now that the only web presence they've got is a WhatsApp account and a Facebook, which is great until you're like, well, WhatsApp and Facebook are down, let's go and have a beer. Oh no, we can't find any bars because they've all gone down with it, URLs, World Wide Web, SMTP, POP3, IMAP, these are open protocols that nobody can stop you using. And this is the wonder about the internet and the World Wide Web. Now, you notice there we jumped over Q and V. Q is the quote of the day protocol. This was 1970s Twitter. You connect to any machine on port 17 and it gives you back today's message up to 512 characters of ASCII, which is kind of cute. And V is for Vermal, the virtual reality modeling language from 1995, which any day now somebody has this thing off and try and get metaverse investment by saying they're building a Vermal browser for Oculus Rift. I put these two in as examples of things which looked like a really good idea at the time, and then they just kind of died away and fell by the wayside, because no one really uses quote of the day or Vermal anymore, but they have every right to stand a long time. The work that went into them was every bit as valid as all these other things we're looking at. Now, X is for XML. Well, X isn't really for XML because the X in XML stands for extensible, which starts with an E. It could be for XSD, but XML schema, well, the X kind of stands for XML, so I refer you back to point 1. Could be XSS, which is cross-site scripting, but no, that's not even an X. Maybe X is for X, which is X, and it's not called X Windows. It's X, or the X windowing system, and it's called X because it was a hack of W, and W ran on V, and that's absolutely true. V was a research operating system at Caltech in the 80s. W was the windowing system. This is hackers who don't like typing more than one letter. Like, W, yeah, there we go, bang, that's it. And someone ported W to X, and it's literally just called X. And X can't be short for X. Like that, I mean, I know www is short for World Wide Web, even though it's longer, but X can't be short for X. So the X in our history here, if you have kids with picture books, X is for xylophone, because it always is. And so this one hasn't been invented yet, but X is XCP, which is the Xylophone Control Protocol, for playing xylophones over the internet, which we all need. So, and if any of you wants to invent it, send me a thing, I'll put it in the next version of the talk. From X to Y2K, which that was a big deal at the time because they thought we were all going to die on the stroke of midnight because all the planes were going to fall out of the sky, and literally there were stickers everywhere. Remember, turn your computer off, or it'll come alive and eat your family, or corrupt all your Word 97 documents or something. And now Y2K, yeah, there's one school of thought that's like, we spent a huge amount of time and money fixing all the things, and then nothing went wrong because we'd fixed all the things. And there's another school of thought that goes, every time we have hired developers to do anything, they have blown the deadline and the budget. We don't think we got it right this time. We think you just got lucky. I don't know who's valid. I know that the world did not end because of digital meltdown at the stroke of midnight on December 31st, 1999, although I did wake up with a hell of a hangover. But we have another one of these coming up. We have the epocalypse, because this is the number of seconds since midnight on the 1st of January 1970 Universal Coordinated Time, and this is the maximum value of a signed 32-bit integer, which means this is the number of seconds left before all the 32-bit Unix systems in the world overflow and no longer know what time it is. Now that's kind of a big number, but it's this many hours, 5,000 days. Now, you can look at this one of 3 ways. 1, 5,000 days till everything melts down. Let's all go out and have fun. 2, 5,000 days, we'll all be running 64-bit operating systems by then. Or, hey, I'm a 32-bit embedded system who knows C. 5,000 days till I get rich. Because there will be people out there running systems who are like, we need people who know 32-bit C and Unix to go and fix our epocalypse Y38 problem. And so we have seen ACK, BBC, CPM, DOS, the Electronic Frontier Foundation, the FBI, the GNU Project, HAL, IBM, JSON, Kibibytes, local area networks, MP3s, NFTs, one laptop per child, POP3, quote of the day, the RFC, simple mail transfer, TCP, URI, Vermal, World Wide Web, XML, I put that one in, Y2K, and that brings us to ZOI, or ZOI. And ZOI is one of the fundamental principles of data structure and systems design. It stands for 0, 1, infinity. These are the only 3 numbers that matter when you are designing a system. If we design, say, an aircraft allocation booking system, we have an aircraft, and we have an aircraft type. What is it? Airbus 380, Airbus 320, Boeing 727. And every aircraft has to have exactly one type. And every aircraft type can have 0 or more aircraft. 0 to infinity. That's our model. And an aircraft can be assigned to flights. And we say, well, an aircraft can do 0 or more flights, and a flight has to have 0 or 1 aircraft, because we might not have decided what plane is flying that flight yet. And the flight can have passengers. And we say, all right, well, a flight can have 0 or more passengers, because maybe we're not selling tickets yet. And a passenger has to have 1 or more flights, because if they don't have a flight, they're not a passenger, and they have no business being in our booking system. The reason we do this is because if we didn't, we'd end up with databases that look like that. And we'd end up with code that looks like this. And then someone would say, Bob, we sold a 5th ticket. And we'd go, oh, crap. That's going to mean changing the database. And so we're like, all right, well, we can okay, we've added another column for passenger number 5. And then we're going, oh, okay, we're going to need to do all right, get the database live, and then we'll follow up yesterday or tomorrow with the new release of the code, and we'll get that out there. And this is why the only numbers we care about are 0, 1, and infinity. Because you can have none of something, you can have one of something. If you've got 0, 1, in the UML, this is known as optionality. And the whole can you have 1 or can you have infinity, this is known as cardinality. And so we build systems that look like this. Yeah, flight, passenger, put on as many as you want, and we'll verify it later using a rules engine or something. And we use lists. We don't have Now, I have worked on software that's customer 1, customer 2, customer 3. Enterprise CRM systems love this, and it's horrible, and I hate it, but it does exist, and that's why we won't do it. And the best way to remember this is something I call the Beer Law of Cardinality, which is you should design software the same way you plan a night out. Are you going to have 0 beers? Are you going to have 1 beers, or you are going to have potentially an infinite number of beers? Because no one ever, we're going to go out for 5 beers. Like, that's not a plan that any sensible person ever makes. You're not having any, that's cool. You're going to go and have 1? All right, 1. Because after 1, you're still like, no, I'm sensible, I'm going to go home now, I can probably still drive. Or you're like, we're having an unbounded number of beers where potentially we may need to scale to infinity here. That, friends, is the A to Z of software history through the medium of 3-letter acronyms. Thank you very much.